Okay. So is the screen is visible to you? Hello.
Yes, sir.
Means this,
YouTube video.
to draw cam profile of oscillating follower, roller follower. Yes or
Yes,
no?
yes, yes.
Okay. Now see what's new in this case. Most of you know how to draw displacement diagram, how to draw cam profile when the motion is SHM here. You can see. So when the motion is SHM during rise, during return, then how to draw displacement diagram already discussed with you. So that is not new for you. But the thing is when the follower is oscillating follower, then what change is there in in a displacement diagram or in a cam profile drawing? That we will discuss today. So what given data is, in given data, you know you see the sequence here. Angle of rise, theta O means angle of rise is 90 degree, and the motion given for the stroke is SHM. Theta D, there is dual period, again the angle is 90 degree, and you know during dual period there is no such a motion as the follower is stationary. Then during return stroke, the angle is 90 degree and the motion is SHM. So during both strokes, that is upward stroke and downward stroke, or you can say rise and fall, the motion is SHM motion. One more thing here is given here. The angle of oscillation is 20 degree. So that is new thing. And why that angle of oscillation is given, that we will discuss in subsequent slides. Okay. Here, one more thing. As the follower is roller follower, oscillating roller follower, roller radius is given, which is 7 mm. Okay. So now how to start, how to draw this, we will discuss one by one. So what important one is here, and length of the follower arm, that is called as OA, is 8.4 centimeter. So you know the oscillating follower means the follower is oscillating, and that follower arm length must be given, and that length is given. So it is 8.4 centimeter is OA. OA means length of the follower arm. You can see here also it is mentioned OA. Okay. Now it is 8.4 centimeter, and this angle is 20 degree. Angle of oscillation is 20 degree. So with this, let's say before, can you anyone observe here? Stroke length is not given. Length of the follower stroke is not given, or maximum displacement of follower is not given. And if stroke length is not given, if maximum displacement is not given, then we can't draw this displacement diagram, as y-axis distance is not known to us. So to get this S, to get this displacement, we need to draw this construction here. So what to draw here? Basically, we'll draw OA length first, which is given 8.4 centimeter. Now it is marked here 7.6, but actually whatever given it is, that we have tried. So 8.4 centimeter we have to draw here. Why 8.4? It is nothing but a follower arm length. How much that length of the arm is, and it is oscillating like this from OA to AO dash, or AO to AO dash. It is oscillating. But through how much angle? So first mark this, that distance, which is nothing but a follower arm. Mark that distance as equal to AO. Then draw 20 degree angle. You can see here that it is 20 degree angle. Draw 20 degree angle. Why 20 degree? Because it is given here. Theta, angle of oscillation, is at 20 degree. So draw 20 degree angle and just draw arc. So this arc length, you have to calculate arc length approximately. It is 2.65 centimeter here. Means we know arm length, we know angle. Just draw arm length and rotate it through the given angle. Let's say 8.4 centimeter. I'm rotating through 20 degree. Then whatever the arc cover, distance covered by the arc, is nothing but your stroke length. So in this case, O dash distance, you can see here from O to O dash, this distance is 2.65 centimeter. Are you getting how to find out? Yes. Yes, you're getting how to find out stroke length. Hello.
Yes, sir.
Yes. Can anyone tell me how to find out? Yes, stroke length. That is only new thing. Otherwise, the displacement diagram is same. Because SHM already we discussed. Can anyone tell me how to draw this? How to find out? Yes, basically when the follower is oscillating follower.
So we have to take the arm length,
Yes.
8.4. Then
Okay.
we have to take the angle 20 degree. And whatever is the arc length, that is the stroke length.
Very good. So basically, just we need to take arm length. In this case, it is 8.4 centimeter or whatever distance it is. We have to take arm length. Just draw a line with that. Let's say AO here. AO is arm length. Rotate it through angle of oscillation. Now, in this case, that angle of oscillation is 20 degree. Hence, I rotate it through 20 degree. So AO moves to AO dash. So distance traveled by end point of that arm, that is O to O dash, is nothing but your stroke length or maximum displacement of follower. That is simple procedure to get follower displacement in case of a oscillating follower. Once you get that, the procedure is same. So can anyone tell me now? We have to draw this. We know yes, 2.65 centimeter, and hence we will select one suitable scale. Let's say 1:1 on a y-axis, and some suitable scale on x-axis to draw a theta diagram. Now, can anyone tell me how to draw this S theta diagram? Because already we discussed for simple harmonic motion. The procedure, please. Only finding S is different. Otherwise, the procedure remains same. Yes, anyone?
Name the points and project it.
Very good. See, we have to see the sequence first. Let's say on y-axis, I have to draw how much distance here? Please reply. How much distance I mark here on y-axis? How much this height of this S is? Yes, how much it is? In this case,
2.65.
2.65. So mark this distance 2.65. That is only new case. If you are unable to get that distance, then we can't find it. Okay. So 2.65 is the distance. I mark that distance here. After that, on x-axis, on y-axis, I take scale 1:1. That is 2.65 centimeter, 1:1. On x-axis, I have to see the sequence first. In this case, it is theta O, theta D, and theta R. How much angle it is given? 90 degree, 90 degree, and 90 degree. I told you in the previous session also, for a dwell period, there is no need to take more distance. So 90 degree of rise, for 90 degree, I take scale as, you can see here, theta O, 1 centimeter is equal to 15 degree. 1 centimeter is equal to 15 degree, means 90 degree is equal to how much centimeter? Yes?
6.
6 centimeter.
So for theta O and theta R, this 90 degree on x-axis is taken by, is represented by 6 centimeter. So theta O is equal to 6 centimeter, theta R is equal to 6 centimeter, and dwell period in between is again 90 degree. But for that dwell period, as it is, there is no follower motion, we just take different scale. 1 centimeter is equal to 45 degree. And as 1 centimeter is equal to 45 degree scale for dwell period, is that distance is 45 into 2, that is 90. So it is 2 centimeter. So 6 centimeter for rise, 2 centimeter for dwell, and again 6 centimeter for return stroke. Okay. Likewise, we mark x-axis, and now after getting that distance, so 6 centimeter distance, I divide into 6 parts. It is very easy to divide into 6 parts if the distance is 6 centimeter, because each division is equal to 1 centimeter. So I mark that divisions here. We divide x-axis into 6 parts. That is for rise, and for return also into 6 parts. Now after that, we also divide this semicircle. Actually, we mark semicircle, and diameter of semicircle is equal to S, stroke of the follower. So after getting that semicircle, divide that semicircle also into 6 parts. Why 6 parts I am repeating? Because I divide this x-axis, rise and return into 6 parts. Just see for SHM, how many parts x-axis is divided. As here in both cases SHM is there, so divide into equal parts. That is important. If both motions are same, then only it is essential to divide both parts, that is rise and return, into equal parts. If different motion, then there is no need to divide into equal parts. You may divide into any number of parts. So here I divide both into 6 parts. SHM, the y-axis into y-axis circle, semicircle I am saying, generating circle, also into 6 parts. Now next part is naming. As this part is discussed with you in the previous sessions, we will not give more time for this. So you can see here, the names are clear. It is 0 to 6, 0, 1, 2, 3, 4, 5, 6 for rise, then 6 to 12 for return. And again, if we call this points on semicircle as 1, 2, 3, 4, 5, 6. Now next step, you know, we have to take projections from semicircle till vertical projections of corresponding points. So you know, if I draw projections through 1, let's see here, from 1, I have to draw a horizontal projection till it intersect projections, vertical projection through 1, and so on. So when projection of 1, that is horizontal projection of 1 and vertical projection of 1 will intersect, that point will be 1 dash. Similarly, projection of 2 and 2 dash will intersect, that will be 2 dash. Likewise, we get 1 dash, 2 dash, 3 dash, 4 dash, 5 dash by intersection of projections, that is horizontal and vertical projections. So you can see that now. Just we are drawing projections. Now this is 1 dash, projection of horizontal and vertical projection of 1, intersection, it is 1 dash. Next, just draw projection through 2, horizontal projection parallel to x-axis, up to a vertical line through 2. You can see up to, actually this line should be up to 2. Now up to 3. You may draw a line further also, but we need to take that point on that corresponding line. So projection through 5 and projection through 6. No need to draw projection as already point is there. Okay. Now get this point as 2, 2 dash. Next 3, 3 dash, horizontal projection of 3 and 3 dash, intersection of that 4 dash, 5 dash, and finally 6 dash. So likewise, we get 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash on a intersection of horizontal and vertical projections. Now join these points by a smooth curve. That curve will be a displacement diagram or displacement curve for a simple harmonic motion. When oscillating follower moving with a simple harmonic motion. Remember, here we are in displacement diagram, you need to think about which type of motion it is. As the motion is SHM, so we are following procedure that already discussed. Now here, can anyone tell me how we draw for return stroke? Yes. How to draw for return stroke now? Because motion is same now. How to get points? Next point is 6 dash, 7 dash, 8 dash, 9 dash. How to get the points? Yes. Already SHM is discussed many times. Yes, please. How to get points in the return stroke? Yes. Don't know?
Take corresponding points on the other side.
Yes. So already in the last lecture also we discussed. As we know that 5 dash is 5 and 7 is corresponding point, 4 and 8, 3 and 9, 2 and 10, 1 and 11, and similarly 0 and 12 are the corresponding points. So take their positions in the next part, we'll get corresponding points. We'll get similar points. So just see that now. So this is end of dual period, again 6 dash. Why 6 dash again 6 dash? Because it is stationary. Follower is stationary, there is no motion. Now in return stroke, just we need to, as the motion is system again, we need to project that point in the return stroke. Let's see how we'll do it. So projection of 5 dash up to projection through 7, 4 dash up to 8, line through 8. Just we can take projections, what horizontal projections we want. Then up to 9, 2 projection up to 10. They're the corresponding points. And the 1 up to 11. Finally, there is no need to take projections at 0 and 12 on x-axis only. Now get similar points as 5 dash. You can see on a circle, we mark here after 6. Again 6 is there, but after 5 there is 7. So 7, 8, 9, 10, 11. So this line represents projection of 5 and 7. This horizontal line represents projection of 4 and 8. This line represents projection of 3 and 9, 2 and 10, 1 and 11. And this is 0 and 12. This one is 6. So likewise on the corresponding again here. So this one is projection of, for return part I will say this is projection of 7. For return part this one is projection of 8. This one is projection of 9, 10 and 11. So get corresponding points when the horizontal projection and vertical projection of that point meets. Likewise we can mark now 7 dash, 8 dash, 9 dash, 11 dash, 12 dash. So this one is 7 dash, 8 dash, 9 dash, 10, 11 dash, and finally 12 dash. Okay. Now join this curve by smooth curve. Join these points by smooth curve. And when you complete it, then this is your displacement diagram. So again, the motion was SHM only, but what new was S was not given, and that we find out by considering this arrangement. That is only new thing here. Now the follower is oscillating follower. So for oscillating follower, how to draw cam profile? For drawing that, just we need to draw one circle, and if you can see here, the length we are taking in the circle is, just we initially you observe how much length we are taking first. In the scale, now tell me what distance we taken here. Yes, please observe it. See, as the oscillating roller follower, can anyone tell me? I've shown you that, but you are unable to understand. But okay, I think here it is there. We know that radius of base circle is 20 mm. It is given to you, and we need to find out radius of the, as it is roller follower. In roller follower, there are two circles. Remember, if it is knife edge follower, flat face follower, or any other follower, then only one circle is there. RB we have to consider. But whenever there is roller follower, I explained in last video also, whenever there is roller follower, we need to draw two circles. That is, along with the base circle, we need to draw prime circle. Here, radius of base circle is 20 mm. And radius of the prime circle is nothing but, it is known to you, radius of prime circle is equal to radius of base circle plus radius of roller circle. How much radius of roller is given? 7 mm. So when, in case of roller follower, in additional, we must know what is roller radius. It is given to you generally. So add that, we will get prime circle radius. So now we need to draw two circles, RB and RP. Okay, so RB is 20 mm and RP is 27 mm. I think in the last lecture also I told, someone asked me why to draw RB. I think Ashbin asked me. Okay, at that time I also told you, you can draw directly RP also, but try to draw RB as it gives you clear idea about cam profile drawing. So I drawn these two circles. One circle is of radius 2 mm, or you can say 2 centimeter. Other one is 2.7. So this one is, this circle represents RB and other circle represents RP, prime circle. Now, as it is radial follower, the follower first position must be passing through cam center. Let's say this one is cam center. So first position is here. It starts from 0. Depends upon rotation of cam, whether it rotates clockwise or anti-clockwise. So again, repeat, it is same. Means if it rotates clockwise, then I have to divide this cam into a anti-clockwise manner. If it rotates clockwise, anti-clockwise, then I have to divide in a clockwise manner, and so on. So likewise, we'll divide that into theta O, theta D, theta R. But remember here, we need to divide prime circle, not the base circle. Okay, this one is oscillating follower. Now for oscillating follower, some procedure is some different. Up to here it is okay. Oscillating follower, we have to draw RB and RP. Now next, we are drawing here roller follower. That is roller. This is first position of roller. You see here, roller touches the base circle, and the center of the roller is on prime circle. This is important thing to understand. Roller is at the it is touching the base circle, while center of the roller is at the prime circle. You can see the cam profile started here. This is start of the cam profile. Okay, and it should start at this point on the base circle and the end also on base circle. That's why base circle is essential to draw. It gives you clear idea whether our drawing is right or not. If you are drawing base circle, you can directly draw prime circle, but it is for more clarity, base circle you have to draw. So we mark first position of this. Now remember, this position gives what you understand from this. As I mark first position here, From this you understand this follower is a radial follower. Now next, as it is oscillating follower, here we need to take this length. Now by mistake they written 8.4. Okay. So here it is 7.6 centimeter is given. That distance we have to take. So we'll take this is fulcrum point. So take distance is equal to 8.4 centimeter. Okay. So take the distance is equal to 8.4 centimeter. You observe how it is drawn basically. With cam as a center and radius is equal to 8.4 centimeter, draw a circle. Now the length of the follower arm is 7.6 centimeter. Remember, it is nothing but distance between fulcrum point and the, you can see 7.6 is nothing but distance between fulcrum point and the roller follower. The length of the follower arm is this one. So at this point, you can say at this point here, this is fulcrum center. So 7.6 is length of the follower arm. And OA is nothing but distance between cam center and follower center. So there are two distances, 7.6 and 8.4. So this one is follower arm length. It is 7.6 centimeter. And to find out displacement diagram, we are using this distance. So A to the first position of follower, this one is follower arm. It is 7.6. I think these two steps are very important. Can anyone tell me what we done here? How to get that bigger circle and how to get this follower arm length? Two circles we drawn. Yes, anyone? See, in that case, two distances are given to you. One is 7.6, other is 8.4. Basically, that 8.4 is distance between pivot center and cam axis. So this one is pivot center, A point, and cam axis is here, cam center. That is 8.4. So to draw this outside circle, that distance is required. So what we done basically, we take distance between pivot center is this, A point. Actually, we take distance is equal to 8.4 with cam center as a center. Draw a circle of radius is equal to 8.4, which is, remember, distance between pivot center and cam center or cam axis. Once you draw that circle, next on that circle, we know length of the follower arm is here. Means your follower center will be somewhere on this circle. But which point is known to you? As I know the follower arm length with roller center as a first position, we know this first position. Distance is equal to 7.6. Mark arc. Whenever it cuts, that point is your first position of follower or fulcrum, I'm saying. So the procedure is, I repeat again, first draw a base circle radius, then draw a prime circle radius. Depends upon which type of follower it is, whether it is knife edge, whether it is radial or offset. Mark follower positions. This is my first follower position. After getting follower position, we have two distances. One is distance between pivot center and cam axis or cam center, that is 8.4 centimeter. And second thing, length of the follower arm, or we can say distance between pivot center and roller center, that is 7.6. Okay, so that two distances are known to you. In order to get center of the follower, center of the fulcrum, draw a circle of radius is equal to 8.4 centimeter with cam center as center. So once I get this circle, on that circle somewhere the fulcrum center is there. And to get that distance, to get that fulcrum center, we know length of the follower arm is 7.6. So with roller center as a center, draw an arc on this circle, outside circle, to get A point. So likewise, we get first position of the follower. Is it clear?
Excuse me, sir.
Yes.
Sir, 8.6 centimeter कशाचा distance आहे? 8.4.
I repeat again. Remember, length of the follower arm is how much? Is it clear? How much length of the follower arm is? Means this length. It is 7.6. Okay. 8.4 is distance between fulcrum center. Means fulcrum center means the point about which follower will oscillate. Distance between fulcrum center and cam center. 8.4. I repeat. Distance between fulcrum center about which follower oscillate and cam center is 8.4. Clear? Hello?
Yes, sir.
Okay. So distance between cam center and fulcrum center is 8.4. Distance between, you can say follower arm, or you can say distance between fulcrum center and roller center is 7.6. हे दोन distance कळलेत का? Because these two distance are important. In oscillating follower, two distance are given. I repeat. One is distance between cam center. Here it is arrow. I think arrow is visible. Distance between cam center and fulcrum center is 8.4. You can see this triangle. This one is 8.4. While distance between fulcrum center and roller center is 7.6. Now whatever the distance it is, but two distance must be given. One is distance between fulcrum center and cam center. Other one is distance between fulcrum center and roller center. And this distance between fulcrum and roller is nothing but a follower arm length. Sometimes it is called as a follower arm length also. I think it is clear now. Oscillating follower, it is time consuming to draw, but it is very easy. Yes. Is it clear? These two distance are clear, and what we drawn up to here, it is clear.
Excuse me, sir.
Yes, please.
Sir, initially when we use 20 degree to find S, that time which length should be considered, 8.4 or 7.6?
Yes, that will be follower arm length. That is 7.6. I think
Okay,
by
sir.
mistake I told you 8.4. Okay. That is your follower arm length. In order to find S, we have to use follower arm length. That is nothing but distance between fulcrum center and roller center, and it is given 7.6. You can see here it is also taken 7.6 only. Yes, here you can see this one is 7.6 centimeter. That is nothing but arm length. Is it clear? Hello?
Yes, sir.
Okay. So use that follower arm length to get distance. Yes. And now in the cam profile, I told you explain up to here. After this, you can see now this OA. OA represents distance between cam center and fulcrum center. And this, you can say first position 0. Let's say 0, or you can say O dash. Let's say this represents your fulcrum length, or you can say distance between fulcrum and roller center. Now next. Okay, now just I will show you video only. After getting these distances, that is OA, marking OA, that is this arm, and then marking this roller center and fulcrum center. Next step is you have to divide this circles drawing into theta O, theta D, theta R. But remember, start division from which point it is important. Start division from this OA. Means line joining cam center and fulcrum center. We have to start from that point. So start division. See what difference here is. Generally, we start division from this radial one. Means from roller center to cam center, we start division. But in case of oscillating follower, as the fulcrum center is not roller center, there is difference here. Means the roller is oscillating, follower is oscillating. So it is oscillating up like this. It is oscillating here about this point, but the center is this one. So start division from line joining fulcrum center to cam center. So that line is OA here. So start division from this O to A. So this is your baseline. From this I will take 90 degree. And you can see how it is taken 90 degree. From this one, take angle is equal to 90 degree. Why 90 degree? Because theta O is equal to 90 degree. I think it is clear from which line we have to start division. Is it clear?
Yes, sir.
From which line? Yes. Yes, please.
From AO.
AO. Yes. AO is the name, but we can say from line joining cam center to fulcrum center. From that line, we have to start division. And in the sequence, in the same sequence, the procedure is same again, division here. So O to A divide into the number of parts as we taken in case of displacement diagram. So 90 degree, again 90 degree and 90 degree. So start division like this. Here the first theta O is 90 degree and hence mark 90 degree here. You can see this one is 90 degree. That is theta O. And we are considering with reference to this OA. So this one is 90 degree theta O. Join with fulcrum center. Now a fulcrum circle we can say. I can call this outside circle as fulcrum circle. Then theta D. So theta O, theta D, 90 degree, 90 degree. And you remember, I think you remember, theta R also 90 degree. So with reference to that, next division from theta D will take return stroke. So this one is theta R. So theta O, theta D, theta R we mark. Now you see here difference, there is some difference between oscillating forward and other forwards. In other cases, we are considering with reference to prime circle. But here we are considering, now we are joining, or you can see, we join this, we divide not prime circle, but the oscillating circle. Now how many parts we taken for rise and return? 6 parts and 6 parts. 6 parts for rise and 6 parts for return. And hence, similar parts we have to take during rise and return on a cam profile. So 6 parts we have to consider on theta O, 6 parts on theta R. Each division is equal to how much degree? Total is 90 degree. So each division is equal to
15.
15 degree. So theta O 15 means I'm saying theta O each division is equal to 15 degree. Mark that 15, 15, 15 degree. That is 6 parts. Okay. So here you can see now. Dwell period no need to divide. Return period we have to divide. Now join. You can see where we are joining this. In the last case, of course, we are it is radius, so we are joining with a fulcrum circle. So join with, mark this divisions on fulcrum circle. Actually, we have to draw lines, but okay. See what we are doing basically, we are marking the divisions on fulcrum circle, and where we are drawing lines, we'll see later. First, see how we are joining it now. Means whatever portion we divide, theta we divide into 6 parts. Just mark it on fulcrum circle. Now I hope you understand the red color circle is fulcrum circle. How much radius of that circle is 8.4. And we are calling ABCD. See here carefully now. ABCDE. So we divide into 6 parts. That is theta O into 6 parts. Now next we have to divide theta R again into 6 parts. As the distance is 90 degree, angle is 90 degree only, each division again corresponding to 15 degree. And we get similar points on fulcrum circle. Remember these points we are marking on fulcrum circle and calling them as A, B, C, D like that, names. Up to F. At the start of dual it is F. So at the end of the dual again it is F only. Further G, H, I, J, K and L. So this is division of fulcrum circle according to displacement diagram. Remember it is important. Divide according to displacement diagram. After this now, see what we are drawing now, doing now basically after this, we need to mark follower positions. So this position is first position from this O to this 0 to we can say this one A point. So this mark position is first position. Similarly, this one is first fulcrum center. Next fulcrum center is here at A. Next fulcrum center is at B, C, D, E, F, and so on. So when fulcrum center is changing, follower position also get changed. This roller position also get changed. Where the roller is, that we have to mark now. You can see now roller center is on prime circle. So we have to mark it, that position of the roller circle on a prime circle. And for drawing position of roller center on a prime circle, we will take distance is equal to length of the follower arm, which is 7.6. So by taking distance is equal to 7.6, center as A, B, C, D, E, F, mark arcs on roller circle, sorry, on a prime circle. I repeat, with distance is equal to length of the follower arm and center as A, B, C, D, E, F on a fulcrum circle, cut arcs on a prime circle to get position of roller or position of follower at every position. Let's see it. So distance we taken is equal to length of the follower arm. You can see the first position is known to you. So according to that we take that distance will take. Now with this centers A, B, C, D, E, F, G, H, we can mark the arcs. First one. Now second position is at A. This one is first position. We see we are marking roller circles, roller positions. Okay, second position, cut arc on a prime circle. Next, B as center, cut arc on a prime circle, and repeat this. So C arc on a prime circle. Remember, we need to cut arc on a prime circle. Okay, and then we have to mark. Once you get point on a prime circle, from that point we'll mark distances. Other procedure is similar to roller follower procedure. Just only these things are new. Okay, you see these are 6 divisions corresponding to rise. 1, 2, 3, 4, 5, 6. Now for dwell, this is F to F is dwell. Yeah, this one. The position for G, then for H, we need to mark point on a prime circle and corresponding arc to get follower displacement. On this arc, we need to mark follower displacement. The arc we are getting with center as G, H, I, J, K, and last one is L. Okay, so last one is L here. You can see. After this, we get these points on a prime circle. Correspondingly, we need to mark follower positions now. And to get follower positions, we need to use distance from a displacement diagram. So this one is first position. See, 0, 1, 2, 3, 4, 5, 6 are the positions of a roller center. 1, 2, 3 corresponding to C, 1 corresponding to A, 2 corresponding to B, 3 corresponding to C, 4 corresponding to D. These are the roller centers. 4 corresponding to D, 5 corresponding to E, and 6 corresponding to H. These are the roller centers when the follower is moving around the camp. Again 6, 7, 8, 9, 10, 11, and 12. Okay. Now 12 is known to you, 11 is known to you, 1, 2, 3, 4, 5, 6. That means up to 1 to 12 are known to you. How to get 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, that we need to discuss now. So to get 1 dash, 2 dash, 3 dash, 4 dash, see the procedure now. And of course, we need to use distance from a displacement diagram. So 1, 1 dash as distance from displacement diagram, 2, 2 dash, 1, 1 dash, 3, 3 dash, 4, 4 dash, and so on. We'll transfer similar distances here. So distance, that is 1, 1 dash from displacement diagram, cut arc or cut, now I'm saying mark that distance on an arc already drawn. So 1, 1 dash as a distance, you can use compass also here. No need to take scale always because it is easier to draw with compass. So 1, 1 dash. So we are marking that distance. So 1, 1 dash we mark. Similarly, we have to mark next points. It is 2, 2 dash, and so on. Okay. So similar distance we are transferring. So we are getting 1 dash, 2 dash, and so on. After getting these distances, see, we are getting points as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, up to 12 dash will get. So these are the points from 1 dash to 12 dash. How we get this is, it is clear. Just transfer distances from this. Now next one is important. As the follower is roller follower, I told you what actually 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash is. This 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash are nothing but roller circles, roller centers. So with these points as 1 dash to 12 dash as a roller center, draw rollers. As procedure for roller follower is discussed, draw rollers and then draw a smooth curve passing through base of these rollers. So try to draw roller circles with almost radius is equal to 7 mm is known to you. It's given to you, roller radius is given to you. With radius is equal to roller radius and center is equal to 1 dash to 12 dash, draw roller circles passing through these points 1 dash to 12 dash. Just see it. So first one already drawn, first portion already drawn. That is 0 position. First one, 1 dash as center, draw a circle, that is roller circle. Then 2 dash. And you see now how we are drawing. If any doubt till now, please ask. Just we have to draw circles with roller radius is equal to given roller radius, whatever it is. In this case, it is 7 mm. Centers as 1 dash to 12 dash. You have to draw rollers. No need to draw complete circles because we need to draw tangent to this base of the roller circle. So we are just drawing part of the roller circle so that we'll get base part of the roller circle. No need to draw top part, upper part. If you want, you can draw complete circle, but just it is okay if you draw only the base circle, base part of the roller circle. Then again, similarly, we will draw the roller circles for the next part. Okay, we'll draw this. We draw these circles. Now, after getting the circles, just we need to draw tangent to these circles, base of the roller circles. You see, the curve is tangent to the base of the. And you can see the curve is started at the base circle. It started at the base circle here, and it must end at the base circle. So this one is portion, well played. Base circle. Yes. Tangent to roller circles. Start and end at the base circle. That's why it is essential to draw base circle. And I also told you in the last lecture, when dual period, you can draw directly by arc. So 6 to 6 dash O as center for every case, whatever the follower it is, whichever is the follower it is, just join them 6 to 6. Actually, we are dividing into 6 means I'm saying start of dual and end of the dual by arc. No need to draw by other simple curve. You can draw directly arc. As the radius is same here, follower is stationary here. It will not move. So this is your follower curve. When the follower is roller follower. Okay, procedure is clear. It is time consuming procedure, but this is only the, I'm saying lengthy procedure for a Kaman follower when follower is oscillating follower. That's why it taken slowly. But I hope you understand. If any doubt, please ask. Otherwise, I will repeat at one time and then we'll close this topic. That is oscillating follower. If any doubt, please ask. All of you just go through procedure. Start from first step to last step. Just try to see whether you are recalling, whether you are calling or not, recalling or not. आठवतं का नाही check करा. Otherwise, ask me. Step by step procedure, please. Given data काय दिलाय आपल्याला आणि आपण कशा प्रमाणे ड्रॉ केले. I'll wait for 1 minute. I hope you are recalling that. Yes, anyone please? Step by step procedure. Yes. Yes, no one remember this? Hello? अरे समजलं की नाही समजलंय प्रोसिजर अजून? Okay, let's discuss one by one. What is your first step? Yes, please.
Find the stroke length.
Yes, right. When it is oscillating follower, only new thing is what is the motion? Already all motions we discussed. So we know how to draw a diagram for a SHM, the uniform motion, uniform acceleration and retardation, and again for a sinusoidal motion. But in this case, generally S is not given. So in order to find displacement of follower, we need to use follower arm length, the distance between fulcrum center and roller center. I repeat, there are two distances given in roller oscillating follower. One is distance between fulcrum center and roller center. That is nothing but follower arm length. Other distance is given distance between fulcrum center and cam center. That is 8.4 in this case. So from that, use distance of follower arm length, that is distance between fulcrum center and roller center. Use that distance, rotate it through angle of oscillation which is given to you. Then we get stroke length. Accordingly, once you get stroke length, whatever motion it is, either it is SHM or any other motion, draw displacement diagram. After displacement diagram, you have to, as it is roller follower, I have to draw base circle as well as prime circle. So draw radius of draw two circles of radius is equal to RB and RP. RP is nothing but prime circle radius, which is equal to radius of base circle plus roller circle. After getting these two circles, I'm telling you the first step is draw base circle and prime circle. After getting this, can anyone tell me what is next step if you remember? This diagram is in front of you. Yes, please.
Draw the roller.
Okay, mark first position of roller. And so mark position of roller, here it is O. Draw that roller circle. After that, next step, yes, please. Important step.
सर रोलरची फर्स्ट पोझिशन आपण कशी मार्क केली ती?
Roller first position means, you know, the first position is at the, as it is radial follower. Okay. So first position must pass through cam center. Draw perpendicular through cam center O. Vertical line through O. Whenever it cuts prime circle, that point is your roller circle.
ओके सर.
Always, it is not only for this, for any radial follower. The first position is that only. Just draw vertical through cam center. Now, in case of roller follower, that is prime circle. For other circles, whenever it cuts base circle, that is your first position of a cam profile drawing. Okay. In this case, it is prime circle. Okay. So we get first position. Next, after getting roller circle, next we have to, we know which two distances we are knowing. Yes, please. Which two distances we know?
Between fulcrum center and cam center.
Good. So we know distance between fulcrum center and cam center. Now center as cam center, O as cam center, that is O as center of the circle. Draw a circle equal to radius between fulcrum center and
Cam
center. So that is OA as radius. Draw a circle. That circle represents fulcrum centers at different positions. Now after getting this circle, we know this distance of 7.6. We know roller position. As roller position is known, means out of these 2 points, say I know this length and 1 point is known to me. So I just mark that arc with O as center. Somewhere whenever it cuts that A point, whenever it cuts that fulcrum circle, that point is A point, which is your first position of fulcrum circle. So A is representing fulcrum center, O representing roller center. Let's say 0 representing roller circle, roller center, and this O represents cam center. So I draw a circle of 8.4 radius here. Then on that circle we mark arc with roller center 0 as center, and 7.6 as arc to get A point. Once you get these 3 points, then it's very easy task. What is next step then? Tell me. We know O, 0 and A. Next step. Let's say instead of O, it called as O dash actually. O dash. Yes. Next step.
Mark the divisions for theta O, theta D, and theta R.
Very good. Mark divisions for theta O, theta D, theta R. But from which line we have to mark that? That is important.
The line which is drawn between OA.
Yes, good. OA line. Now what OA is? It is nothing but line between cam center and fulcrum center. Remember, in other cases, we start division from this first position of roller. Generally, we start from O dash. But as here, fulcrum position is here. Hence, for oscillating follower, we start division from OA. In other cases, we start from this first position of roller, that is line joining cam center and roller center. Is it clear? If it is roller follower numerical, then we start division from O dash, not from OA. In this case, from OA. Then we know that we divide into theta O, that is as per given data. From OA, we mark 90 degree theta O, theta D also 90 degree, theta R also 90 degree, and remaining again 12. Then divide that theta O, theta D, theta R into equal number of parts as marks in displacement diagram. And so I divide this. I hope you understand which portion we divide here. We divide theta O and theta R into 9, which is 90 degree, into 6 equal parts. And then remember, we are not joined this here. If you join it, it is a complicated one. So just get that divisions. Let's say here it is the 6 divisions we get, and mark that divisions on fulcrum circle, represented by A, B, C, D, E, F, and here from F to F, G, H, I, J, K, L. Once you get these divisions, then again length of the distance is equal to length of the follower arm. That is this distance between fulcrum center and roller center. That one has length, that is 7.6. A, B, C, D, E, F, G, H, I, J, K, L up to as a center, and cut arcs on prime circle to get roller centers. That is nothing but 1, 2, 3, 4, 5, 6, 6 to 12. Clear? So get roller centers on a prime circles. Remember, we take length is equal to A, B, C, D, E, F, G, H, I, J, K as a center, and length equal to followers fulcrum distance between. I'm saying length equal to follower arm length. We cut arcs on a prime circles. So we get these arcs, and now after getting 1 to 12 as roller centers, actually not a roller center, I'm saying as points on prime circles, then get 1 dash to 12 dash by considering distance from displacement diagram. That is 1, 1 dash, 2, 2 dash, 3, 3 dash, 4, 4 dash up to 12, 12 dash, which is here, which is 0 only. So after getting that distance, mark that points on an arc, and now 1 dash to 12 dash as roller circles. Draw rollers equal to radius of roller circle, and then draw a smooth curve passing through bottom of these rollers, tangent to these rollers. So there is no need to draw complete circles, as we are going to draw tangent to bottom of these roller circles. So we get smooth curve when we draw it through bottom of the circles, and for dwell part, we need to join directly by arc. This is your procedure. I repeat first, again fast. Mark first find out yes, then mark RB, RP, mark roller center from cam center. Then by knowing distance between fulcrum center and roller center, draw fulcrum circle equal to 8.4. So draw fulcrum circle, then divide it into equal parts as discussed in displacement diagram. That is from OA we have to divide theta O, theta D, theta R. Then once you get that divisions, mark 1, 2, 3, 4, 5, 6, 12 on prime circle by taking length is equal to fulcrum arc length. Then from 1 to 1 dash, 2 to 2 dash, and so on up to 12, 12 dash. Transfer this distance from displacement diagram. Once you get 1 dash, 12, 1 dash to 12 dash as roller centers, draw circles, draw a smooth curve passing through bottom of these circles. That is your procedure to draw a cam profile for a oscillating roller follower. And of course, the motion in this case is a simple harmonic motion. Okay, is it clear? I know this one is lengthy procedure, difficult to remember actually, but not difficult to remember. Once you practice it, is very easy. Any doubt now in this case?
No, sir.